Okay, ready.
Okay, so first you have to turn this on. This is measuring the concentrations when doing a BCA, which is for Western Blot sample prep. Turn on the computer. Okay, you can pause it, I guess. And then you click the Gen 5, which brings up the plate reader. And then I turn this on. This is your plate reader. And you can click on my BCA KV linear protocol, and that will bring you to the setup. It's loading. You always want to click COM4. Let it load. And this is normal, it does its own setup thing. This happens sometimes. It says it's not communicating, you say okay. And it's gonna do its thing. That's a normal sound. And once it stops making a noise, it's usually ready. It'll come back out. Here it comes. You can go to plate layout to set up your plate, depending on your samples. This is what your standard curves should look like. And then you want to click down here. You want to click that so that when you add them, you can add them sideways, because that's usually how you add them in your plate. And for some reason, this ended up adding another sample 1. And if that happens, you can just go to delete and then just re-add it up here. And if you end up doing them in triplicates, you can adjust that down here. And once you have your plate layout set up, you can click OK. And then, yeah, you can shut it.
Go.
Okay, so when you want to make your new protocol, you click New Task, and it'll bring you to this setup. And then you go to Protocol, and you go to Procedure, COM4, and it'll bring you to this. You want to click Shake, and you want to have it for 0.01, which will be 10 seconds, and in a linear mode. You click OK. Oh. JK, you want it to be for 10 seconds. Okay. You want to go to read, make sure absorbance is clicked. This is all fine. And then click OK. And then you want the wavelength to be 562. You click OK. And you should have these two setups. Alright, and then you want to go to, you want to go to plate layout, and then you want to select your well types. And for a regular BCA, you want to click blanks, standard curves, and then your samples. And then you want to have your blank, and you want it to be in replicates of 2. And you can just give it a name, blank. And then you have your standards. And your standards should be, I think you can pause it. Blank, replicates 2, standard. And it's like certain numbers. 1, 2, 3, 4, 6, 8, 10. Okay. Okay, ready again. And you want your standards in duplicates, and you want them at 1, 2, 3, 4, 6, 8, and 10. And then you want to click next. And you can click up here and write down standard curve. And you click next. And then you have your samples. You want them to be in concentrations. And you want those in replicates of 2. And click finish. And then this should have everything set up. You want to have a blank right here. and then you want to add your standards. So we'll select that, select the 1, 2, 3, 4, 6, 8, and 10. And then when you're ready, you can add your samples, as many as you want, and you can click empty layout if you want. So after it's done incubating in the little incubator for 10 to 15 minutes, you want to check it. It should have an increasing gradient of the purple from green to purple for your standard curve, and then depending on the concentration of your protein, you should have hopefully at least like some variation of color, hopefully something around the middle, because that means you have a good enough concentration to make a blot. You gently put it in here, remove that, remove the lid, and then after you have this all set up, you want to click play, and then you click OK, and they'll buffer a little bit, and then I'll pull it in and it'll start reading it. And if you have this data on the 562 value, it will give you a live read. If you have it on any other value in the drop-down box, it still collects the data, it just won't give you the live read, because that's to calculate it. This is just a straight absorbance values. So when you have your data, and you're ready to export it, you want to click blank 562, because that normalizes your absorbance values to a blank of 0. And you want to click this little button, and that will export it to an Excel sheet. And if I click down here and I go back, I click statistics, and I make sure I have it on concentration, because that's the important value you really want from this. You click the button again, and that will be exported. And then you use the mean values of the concentrations of the certain samples that you want to look at to calculate the amount of concentration you have. And I guess I'll just click, there you go. So for every read, I'll have the blank 562 exported to an Excel, and then also the concentration as I previously showed. And then that will be in for all of the reads once they're ready. And then I have the setup for the reads with my samples, the different concentrations I'm gonna have for the reads, and then I'm gonna calculate the average concentration. So a good way to do this is you select the average mean, and we only want these samples. So I'm gonna copy it, and then I'll paste it. And then by clicking Control, it's J, no, H. No, Control G. Control G, click Special, click Blanks, okay, and that highlights your blanks. Then you right click on a blank and you can click Delete. And then you just have that. And you do that for all of your reads. Okay, pause it now. So depending on how many blots you want to make, you can calculate the amount of sample you need to add to prepare your protein sample for Western Blot. The suggested amount is between 10 nanograms to 15 nanograms, with 10 being the minimum. You ideally want 15 nanograms of protein per sample, and that's per blot. So for here, we have 2 Western blots we're trying to make enough sample for, and we want 14 nanograms each. So that will be a total of 28 nanograms. And you can see in my calculation that I have 28 divided by the average concentration to find out the amount of sample in microliters that I need to add, because our average concentration is in nanograms per microliter. And I just find that calculation and I drag it down to find out the sample amount. And we use a 4x sample buffer to prepare the samples for the SDS page Western Blot. And so every reaction is a 15 microliter reaction. For 2 Western Blots, that means we want 30 microliters. And then we divide 30 by 4 to find out, so that we can dilute our sample buffer to 1. So that will be 7.5 microliters of sample buffer for a total solution of 2 Western Blot prepared samples. And so that leaves us with a final volume of 22.5 microliters that needs to be made up for by our sample protein, our protein sample amount, and our water amount. So I know I have to have a defined amount of the sample in order to run the blot, because that's the whole point of the Western Blot. And then the water is just like a buffer. So I do the 22.5 minus the amount of sample that I have, and that tells me the amount of water that I have. And if you have a negative value, which we did when we had 15 nanograms, you may have to decrease the amount of protein per blot in order to get enough protein in it so that you have an equal amount of protein for your blot to get the best total protein image. You know that if your water amount is a negative value, or if this is above the value that you are supposed to subtract from your water, then you have to decrease the nanograms, and you don't want to go below 10 nanograms. Go. So when you're done, you can X out of that, and if the plate reader is still out, you want to make sure your plate is removed, and you want to go to System, Instrument Control, and then the COM4, and then you want to go to the door/carrier and just click Carrier In, and that will put it in so that you can shut everything down. And then you'll just click close out of the program, like so. You don't need to save it unless you really want to. Just make sure that you can click ignore. You just want to make sure that you have your Excel saved, and then you just shut everything down.